Alright, we're solving this equation that has a square root, and to solve a problem with a square root, we want to isolate the square root. So what I could do is subtract 8 from both sides. There's different ways of isolating it, but I'm going to leave it on the right for right now. So on the left-hand side, I have x minus 7 equals a negative square roots of x plus 5. Now it's true this is not completely isolated, but remember this really just means negative 1. As long as you have the term with the square root isolated, you could leave it, or you could divide everything by negative 1 first. So there's two choices in this. I'm going to leave it just so you can see what happens if you leave a coefficient here. So then I want to square both sides. We have to be careful. I'm squaring a binomial over here. So remember what that means. It means x minus 7 times x minus 7. Okay. Now, on the right-hand side, this is like two factors. You've got the negative 1 squared, and you have the square root of x plus 5 squared, right? That's the rule of exponents. If you have an ab squared, it means each thing is squared. A squared, b squared. So that's all I'm doing there. So let's do the left-hand side. FOIL method, x squared. The outer term is negative 7x, and the inner term is negative 7x. So that gives you negative 14x plus 7 times 7 is 49. It's really negative 7 times negative 7. But this would also be fine to go directly from this x minus 7 squared if you know the formula. Now, negative 1 squared is just going to be positive. So notice what I get over here when I square the square root, I end up with just x plus 5. Now, if you had divided everything by negative 1 first, over on the left-hand side, you would have a negative x plus 7. And when you squared it, you would get exactly the same thing, x squared minus 14x plus 49. So that's the other way to do it. All right, now we have no more square roots, but I do have an x squared term. That's a quadratic. And anytime you have a power on the exponent, you need to set it equal to 0 and then factor to solve. So we have x squared. I'm going to subtract x and subtract 5 from both sides. And that gives me x squared minus 15x plus 44 equals 0. You've set it equal to 0 and factor. This one's not too hard to factor. 4 and 11 is going to work. X minus 11 and x minus 4 equals 0. And then you set each factor equal to 0, right? So x minus 11 equals 0, or x minus 4 equals 0. So x equals 11, or x equals 4. But you need to check this in the original equation. So we need to check both of these in the original equation. So first let's check x equals 11. And the original equation was x plus 1 equals 8 minus the square root of x plus 5. So we're going to plug in 11 for x. So 11 plus 1 is 12. And then we're going to plug in 11 for x over here. 8 minus the square root is 16. 8 minus 4 is 4. So no, it does not check. That is not a solution. So now let's check x equals 4. Again, you just write out the original problem. By the way, if it doesn't check, that's because when you square both sides, you get what's called an extraneous root. Even if you do all the problem correctly, you can come up with something that does not make the original equation true. So let's put in 4 and see what happens. 4 plus 1 is 5. Bring in 4 for x. Underneath the radical, that's square root of 9. 8 minus 3 is 5. That checks. So this is a solution. So if we go back to our original equation, then we have that the solution is 4.